method, which is something called function composition. Is a little bit more sophisticated than the sum, difference, product, and ratio. It's denoted by F, a little circle, G. Of course, of X. How do I read this? F composition, F comp G, F comp G of X. Of course, I can have G comp F of X. I can have F comp F of X. I can have G comp G of X, and so on and so forth. What does it mean, really? It's not addition, it's not subtraction, it's not multiplication, it's not division. So, by definition, F comp G of X is F applied to G of X. So F comp G of X is F of G of X. Meaning, now this is the X value that needs to be plugged in F. So instead of X, I will plug in the function itself. Okay, so let me copy the functions we had and illustrate this mechanism, which is totally different from anything else we talked about so far. So f of x was 4 minus x, and g of x was 2x squared plus x plus 5. I'm going to determine both. I'm going to determine first f comp g, and then I'm going to determine g comp f. Okay. I write the definition, f of g of x. I copy f, and in parentheses, I write g of x. This is g of x. So I put in here 2x squared plus x plus 5. Remember a long time ago, we said, how do I read this function? So the function f of something equals 4 minus something. So now this is my something. This is what I have to plug in x. Because f of something is 4 minus something. So whatever this is, which is this, is 4 minus it. 4 minus, I'll write in parentheses so you can see what happens next. Of course, I have to distribute. 4 minus 2x squared minus x minus 5. I have to rearrange it in the correct order, descending order. First negative 2x squared minus x, and then minus 1. What is this? Totally new. A totally new function obtained by composing f and g. And the domain is totally different. However, it happens that it's the same because they are polynomial functions, but that's good enough. Okay, now how do I determine g comp f? By definition, this is g of f of x. I replace f of x by 4 minus x. And now I look at g. What does g say? G says that g of a function, g of something equals 2 times something squared plus something. Instead of this, I have to replace this. I have to put 4 minus x, because this is what I have now, g of something. Okay, g of this is 2 times that squared plus that plus 5. So I have 2, 4 minus x squared plus 4 minus x and plus 5. One more time. 2 times 4 minus x squared plus 4 minus x and plus 5. Can anyone square this for us? Because we have to square first and then distribute 2. I cannot distribute 2 before I square.
Is it x squared minus 8x plus 16?
Yes. Regardless of how you want to write it, you're correct. So you can write x squared minus 8x plus 16. Very good. And this is minus x and plus 9. Now I can distribute 2x squared minus 16x plus 32 minus x plus 9. And I rearrange it in descending order. 2x squared minus 17x plus 41. What is this? A totally new function. What is it? It's the composition of G and F in this order. As you see, they're not the same. They're not the same. F comma G is this, and G comma F is this. Okay. I want to ask you if you have any questions. Would you like us to choose other two functions to find the function composition, F comma G and G comma F? What if I just add a quick question here before you make a decision? What if I ask, now let's determine G comma F of 0. I have the function, it's right here. 0, 0, 41. Do we need another example with the function composition? Anybody? Do we need another example with function composition? Okay, I just would like to look at a domain, again, of a function like, let's say, 27 on page 312. And the function is g of x equals the square root of x minus 2 over x minus 5. Now, there are two potential issues here. A potential issue is coming from the square root, and another one may be coming from the denominator. Which one would you like to start with? Which of these two?
The denominator.
Excellent. What will you say about the denominator? Definitely, we have to write a restriction. What is?
X cannot equal 5.
X cannot equal 5. In other words, the restriction starts with x minus 5 not equal 0, which we write as x not equal 5. Excellent. Perfect. Now let's talk about the numerator. Is there a potential problem with the numerator? And we discussed this in the last month. What is the problem with the square root?
All real numbers?
No. Only if it's an index that is odd, then yes. But if the index is even, we cannot use all real numbers. What numbers can we use? What numbers can we take the square root from?
2.
So you mean positive. And what else? Any positive number we can take the square root of. And what else? Zero, right? We can always take the square root from positive numbers and 0. We cannot take the square root from a negative number. Remember, we discussed that. The square root of -1 is I. So every time the index is even, we have to make sure that this quantity is greater than or equal to 0, according to this. So x minus 2 has to be greater than or equal to 0. But if the radical is in the denominator, I cannot have 0. So if I have a situation like this, I cannot include 0 because it's in the denominator. So when we solve this inequality, we get x greater than or equal to 2. When we solve this restriction, we got that x cannot be 5. So this function has two restrictions. One coming from the function found in the numerator, because this is a ratio of two functions. So this numerator cannot exist if this quantity is not positive or 0. And the denominator will not exist, and the function will not exist if the denominator is 0. So therefore, we had to exclude 5. So we have two conditions, one coming from the numerator and one coming from the denominator. Good. So we have to find the common domain. The values have to be greater or equal to 2, but cannot include 5. So what is the domain of G? Can anyone tell us what is the domain of this function? How do we write this? Any number greater than or equal to 2, but not 5. Anyone, please?
Would it be, in parentheses, would it be infinity, comma?
We start at 2. Greater than or equal to 2, greater than or equal to 2, and not 5.
2 comma infinity.
So I cannot write 2 comma infinity because I have to exclude 5.
Oh, okay.
So 5 union 5 to infinity. Is this clear? Do we understand the domain?
Yes.
Any real number greater than or equal to 2, but I have to exclude 5. And that's how we write it. Agreed? Okay, so I would like us to look at something like this. Here is use the graph of f and g, the graphs of f and g, to evaluate each composite function. Please choose one of these, or more than one, it's up to you. So let's choose and look at that. Anyone would like to choose 91, 92, 93, 94?
We do 92?
Yes. So let me copy 92. And this is on page 313. And 92 says find f comp g of 1. Perfect. I'll come back to the graph. By definition, f comp g of 1 is f of g of 1. This is the first thing I need to determine. Whatever this is, then I will apply f to that number. So now we have to find g of 1. So let's look at the graph. And let's identify g of 1. G is in purple, f is in blue. Can anyone find g of 1 for us? G of 1. And I would put it, say it again.
-5.
Excellent. Okay, so let me show everyone. So g of 1 means you imagine you draw a vertical line at 1. It crosses the graph of G in this point, and we read the Y value. Perfect. Thank you, Christy. Okay, so this is now f of -5. Perfect. Can anyone find f of -5 for us? Because g of 1 was -5. I replaced g of 1 by -5. And now I need to find f of -5. And that's the final answer.
3.
Yes, indeed. f of -5, x equals -5. It crosses the blue graph, and I read 3. Perfect. So the final answer is 3. So f comp g of 1 is 3. Any questions on this problem? Any questions on this problem? Do we need more examples with addition, subtraction, multiplication, division, and function composition? Anyone, please? Okay, the next thing that we need to talk about is something called inverse functions. So what is the idea here? If we take x, let's say x equals 1, it corresponds, I'm picking some numbers, doesn't matter, to y equals 3. And this is the function f of x. If I apply this function to 1, I get the value 3. If I apply this function to 2, I get the value y equals -2, and so on and so forth. And I have function f. I would like to be able to, just imagine we go from Baltimore to New York, and we want to go back from New York back to Baltimore. So the function f takes us from Baltimore to New York, and we want an inverse function to bring us back. What does this mean? It means that this function, and here's the notation, f, like it has like a power of -1 of x. This is not the way we read it. We read it f inverse. F inverse is the inverse of function f. What does this mean? It means that this function, the inverse of f, when it is applied to 3, it returns 1. When it is applied to -2, it returns 2, and nothing else. So 1, 3 is a point of the function. 2, -2 is another point of the function. But what will be, can anyone give us the points for the inverse function? So 1, 3, 2, -2. What will be the points for the inverse function in this case? Can anyone try to give us the inverse, the points for the inverse function?
3, 1.
3, 1. Excellent. And?
-2, 2.
Excellent. That's all I needed. So 3, 1 and -2, 2. So these are the x values for the inverse function, and these are the y values for the inverse function. This is all nice and beautiful, but not all functions have inverse functions. Not all of them. Only functions that have a very important property, that are one-to-one, one-to-one. Only functions that are one-to-one have inverse functions. What does property of being one-to-one, or how does a function look like when it is one-to-one? Okay, so let me give you a few examples. This is a function, and here's another function. What does the one-to-one property mean? Remember, by the vertical line test, this is a function. By the vertical line test, this is a function. For every x value, I read only one value. The same thing here. The difference between these two is this. If I cut the function with a horizontal line, and here, for a particular y value, in this case, I read three x values. I read x1, I read x2, and I read x3. Here, for every y value, I only read one x value. One x value for every horizontal line. This is one-to-one. To each y also, it corresponds only one x. This is not one-to-one, meaning it's sufficient to show that for one y value, I have more than one x value, and the function is not one-to-one. Therefore, this function will not have f inverse. F inverse does not exist. F inverse exists. So what does one-to-one mean? Not only for each x there is only one y, but also for each y there must be only one x, which is not the case here. For every x value there is only one y. It's a function. For every y value there is only one x. In addition of being a function, it also is one-to-one, so it has an inverse function. Okay, there is a procedure of finding the inverse. Find the inverse function. How do I do that? So if we go back to a simple example, this is a line. So a line is always one-to-one. It's a function, and it's also one-to-one. For each y value, there is only one x value. So this is one-to-one. Linear functions are always one-to-one. Now the question here is, find the inverse function. You know it's one-to-one. Find the inverse function. For finding the inverse function,